In this video, we are going to learn more about Bridgetek EVE Screen Editor.
Now, ESE is a static screen emulation tool, and we can use our USB to SPI interface to demonstrate the screens we create on our hardware as well. And this is predominantly targeted for people that want to get into the lower level parts of their code and code manually. So, as with ESE, there's a project creation page, and we can give this a name such as color picker ESE. Now, ESE doesn't have the complex widgets that ESD does, but it does include the base widgets that are available for use in EVE projects and are supported by the commands in EVE devices, as well as the primitives and other graphics controls. So, for example, we can copy a text command on here, drag it across onto the screen, and this will give us the command text output in our coprocessor list, which are the list of commands used to generate the screen. We can manually edit this, or we can edit it via the properties window. For example, we can change the text to color picker, and we might want to select a different font. These handles are the inbuilt fonts, but you can use handles for custom fonts if you have generated these for your project. Again, the next step is we need to add in an image to use as our color picker. So if we'll navigate back to this image, and the bitmap conversion utility appears, we'll select again ARGB1555 and hit convert. In the content window here, you can see that the image has appeared, and in the properties window, you can see that it's loaded at graphics memory RAM-G address 0, and it is currently loaded, but we can select to unload or change the address if required. If we click and drag this onto the screen, it produces the code required to render the bitmap on the screen. You can see this here, including a set bitmap and a vertex command. Again, we can manually edit this, or edit these commands via the properties window and move things around on the screen. Okay, so we want an output rectangular box, as we had in our previous application on ESD. So we're going to draw one of the rectangle primitives here. You can see there's a begin rectangles command and a vertex command. Let's copy this to create another vertex for our rectangle, and then we can click and drag this around on the screen as required. So if we're happy with the static screen we have created, we might want to test this on our hardware, and we can do this via USB to SPI. But first, let's check again, as with ESD, we can see the lower level commands used to generate the screen, and ESE gladly provides us with a live emulation of the internal chip registers as well, which can be helpful during debugging. So we have our commands to generate our screen here. We want to test them on hardware, so we can use our 4222 on the ME817 EV again. So let's check that we have our project settings correct. We've got it set for a BT817, and we have the resolution set to WVGA. So there's a multitude of WVGA screens, and we might want to change the settings for these. And you can see that the devices currently only list the emulator, which you can run on ESE. But let's refresh, and you can see that the 4222 has appeared. So let's manage the devices we have. So we've configured a specific device for our DP070101A screen. And this has all the applicable register timing settings for the screen here. So when we connect to the device over the 4222, we want to make sure we're using the settings correct for our screen. So we select this in the devices here, and then we can press connect. This will boot up and connect to the screen and give us a blank screen at start. And then we can use the write RAM-G and RAM command button here to write the command list to the screen and display our screen. So we might want to move some things around. For example, the output rectangle, maybe that's needing resized or positioned somewhere else. And we can do that with the drag and drop nature of this toolchain, and then hit write RAM command and RAM-G update again. And this will reposition it on the screen for us. So this allows us to view what our screens would look like on a real hardware. But what if we want to export this to an MCU? Well, we can via the Export tab. We've chosen an EVE MCU Dev lower level library project here for the Raspberry Pi Pico. This generates a full Raspberry Pi Pico project, which we can import into Visual Studio Code using the Raspberry Pi Pico extension. So let's click on the extension here and go to the import project function and navigate to where this imported project, or this project has been generated. We select import, and this will import the project into Visual Studio Code for us. You can see that the project has a number of files, including the EVE MCU Dev library files, and a common folder, which has the project files in it. For our example, if we navigate to eveexample.c, we can see some library-specific commands here that mirror the commands that we have generated in EVE Screen Editor. So, there's a couple of things we need to do before we build this project, one of which is check the cmake.list file to ensure that the following standard USB is enabled, standard I/O USB. This is to power the development module, and then we want to take the eveconfig.h data from the file in the top level folder and copy this into the eveconfig.h file in the library structure. This is the settings used in ESE to demo our project on the screen, and we want to make sure when we build the project that the same settings are used and pulled into the library. So once this has been done, we can use the extension again to hit compile project. And just like ESD, this will compile a .uf2 file, which can be used to program the RP2040 on our MM2040 EV development module. You can see this appear in the build folder here. So here we have our UF2 file, which we can use to program our screen. So if we press the boot select button on the Raspberry Pi Pico on the development board, this will open the folder which represents the memory of the device, and then we can click and drag the UF2 file onto the device, and this will program the Raspberry Pi Pico with the code we have just generated. And here you can see that the code is now running on the Raspberry Pi Pico, but this is just a static display list with no touch functionality. So I've generated some touch functionality previously, and we're going to paste this into the project now. So if we copy this display list, which includes some functionality to interpret touch inputs and color the rectangular output, and rebuild the project, this again will generate the a new UF2 file, which we can then use to program the MM2040. So similar to before, boot select opens up the memory device associated to the Pico, drag the UF2 file on, and we've programmed the device. Now you can see that the light library that is EVE MCU Dev is running the full application along with the touch input to color the output rectangle from our color wheel.
Elevate your user experience with Bridgetek. It's easy with EVE.